Today we're going to be talking about points of concurrency. Can everybody say concurrency? Points of concurrency, underline that, are when you have 3 or more lines or rays intersecting each other. Today with our points of concurrency, we are going to be doing these in triangles, and I'm going to teach you 4 special points of concurrency. We're actually not going to be calculating anything with these. You are just going to have to look at them and recognize which one it is and what it goes with. That's all you have to do. All right, can everybody put your head up, and we're going to write this down. I'm going to try to take only 10 minutes. We'll see how far I get. The first one, everybody box orthocenter. Can you say orthocenter? Orthocenter is the intersection of what? What do I have here in my picture? Ooh, there's no tick marks. No tick marks. Height. What was the word for height? Altitude. So an orthocenter is when you have 3 altitudes in your triangle and they intersect. So do you see how I have 3 right angles right here? If I only show you one, like this, that's an altitude if there's just one. But if I do it for every single side, that's all 3. That point where they connect is your orthocenter. Okay? And just an FYI, like this one right here, if it is a right triangle, your orthocenter is located on the right angle. So you technically have a right angle right here, and then you have 2 right angles right there. So your orthocenter is on the triangle. If it is an obtuse triangle, your orthocenter is recognized outside of it. What do I need you to know about this? Orthocenter is 3 altitudes. That's all you need to know. Orthocenter is 3 altitudes. Questions?
No, I'm just translating it.
Okay, that's fine. Any questions? All right, next. Let me show you an example real quick. Orthocenter is if a man is designing a new shape for hang gliders, the glide itself will be an obtuse triangle, and he's going to use the orthocenter of the glide, which will be outside of the triangle, to make sure the cords descending down from the glide to the rider are an even length, connecting at one point of concurrency. So that's an example where designers use orthocenter. Okay? Next one is centroid. Everybody say centroid. Centroid is probably the one that is most used in my opinion. And looking at this picture, does anybody want to guess what a centroid is? It's the intersection of 3 midpoints, which we call
segments.
They are segments. What are not mid segments?
Midpoint segments.
What was it called when we just had tick marks? That was when we had tick marks and 90 degrees. Medians. Centroid is the intersection of 3 medians. So, do you see how this has 3 lines? It is a centroid. If you just have one of them, that is just a median. But if you have 3 of them, a centroid can only be inside of the circle, so that's the centroid right there in the middle. And it is the point of gravity for which a triangle will balance. We call this the center of mass. Did anybody growing up have one of those toys where I had it? It was like a hummingbird or something, where you put it on your finger and it like balances on just your finger. Okay, the same concept comes from a median. That obviously they distributed the weight different, but that's what this does. A centroid also divides each median in a ratio of 1 to 2. I don't know why I just put 22. 1 to 2. All right. What that means is, like, let's say this right here, from here to here was 5. Then up here to here would be 10. Again, you're not going to be doing any calculations with this. You are just going to have to look at a picture and recognize that is a centroid. Now, I'll come back to that. Any questions about a centroid? Okay, so I'm going to show you an example in a little bit in class, but if a carpenter is designing a triangular table that had one leg, he used a special point of the table, which was the center of gravity, due to which the table is balanced and stable. So I don't have, my table at home is not triangular, it's circular, but the same concept applies. At my table at home, does your table at home have 4 different legs, or do you have one leg in the middle? I have one leg in the middle, and mine like one leg, yeah. So that one leg in the middle, they are using that the centroid to figure out where that is at. If it were triangular. If it's rectangular, obviously it's a little bit different, but yes. All right, the next one. Everybody say in-center. In-center, can y'all box that word? In-center is when you have the intersection of 3. Oh, this one's hard to tell because it doesn't show it. Can everybody add arches to angle A, 2 arches to angle B, and 3 arches to angle C? It is when you have 3 angle bisectors intersecting. An in-center is special because it is, if you were to draw a circle inside of the triangle, it is the center of the circle. And it can only be inside the triangle. And it's the shortest distance from each side length. It's the shortest distance from each side length. So, let's say there are 3 busy roads that form a triangle. A lot of roads downtown form triangles. It's really weird. You want to open a store that is equidistant from each road to get as many customers as possible. Finding the in-center would help find this point because the center is equidistant from all the sides of the triangle. So that's just an example. Unless you are crazy like me and become a math major in college, you're probably not going to go really into all of these words. Unless the other situation is architecture. Architects a lot of times, and like civil engineers where they're doing like locating and things like that, they do city designers type things. They do a lot of this as well. Okay, but some of y'all are like, ooh, that's what I want to do. But other than that, like, I mean, this isn't gonna come up a whole lot. Okay. Last but not least, can everybody say circumcenter? A circumcenter is the intersection of 3 what? Perpendicular bisectors. A circumcenter is the intersection of 3 perpendicular bisectors. Remember, perpendicular bisectors don't necessarily go through the middle. They can, but they don't go through the opposite vertex. It can be outside of the triangle, and it is equidistant from all 3 vertices. So if I were to make a circle outside of my triangle, it is the center of that circle, and it is the same distance to each vertice. Circumcenter. I went to a concert. Did I tell y'all I went to a concert last week? That's why I was out? No? So I went to a concert, and it was a festival, and so there were 3 different stages. And so what they do is they have 3 different stages across the way from each other. They want to find the circumcenter to, that's where they locate the restroom, because they want the restroom the same distance away from each stage. So people at one stage don't have to go further than people at another stage. So that's an example of circumcenter when people are designing things. They want to design something in a central location, the same distance away, they would do circumcenter. All right, do I need to turn the lights off? Because I see a lot of people dozing off, a lot of people's heads down. Can you pick your heads up, please? Can you make sure you have these words written down? All right. What questions do I have? So, you see the saying at the bottom. All of my classes are bringing in peanut butter cookies. All of altitude goes with orthocenter. My classes, median goes with centroids. Are bringing in angle bisector goes with in-center. Peanut butter cookies. Perpendicular bisector goes with circumcenter. You just have to know which ones go with which. So if this was a multiple choice question and I gave you a picture, would you know, hey, it's a bunch of medians, what does it go with? Centroid. Hey, I gave you a picture and it has a bunch of 3 different arches on it. What is it? In-center. All right, so different things like that. What questions can I answer? Do you want to hear about your extra credit project? Yes? No? Maybe so? All right. Extra credit project. Let me make it so that the people right here. Let's see what the camera looks like. Upside down on the board. Ooh, we're zoomed in. Let's zoom out. Okay. There we go. All right. So, your extra credit opportunity. It is going to be replacing one daily grade. So, if you have a 0 or a low quiz grade, it can replace that. Or, I'm even considering giving you 5 extra points on an assessment just to raise your grade. So, the whole point is to raise your grade. All right? You are going to construct a center of mass or a centroid on a triangle made from wood, cardboard, or some other sturdy material. It must be bigger than your palm. And I'll show you what it does. So, here's an example from, I don't even know, like 10 years ago. And what they did is they calculated the length of each side, and then they did the median for each side. Does that make sense? And it intersected. And where it intersects at, I'm going to take a pen. You are going to have a point where it labeled your centroid, and I'm going to put this on my pencil. And if it can hold up for 10 seconds, you get the extra credit. And that's it. That's all there is to it. All right? So, if I try, like let's say they did it on both sides. Let's say I try right here, and it falls down. That's one try. So you get 3 tries. I'm going to try again. It falls down. All right, a 3rd try. And then last try, it worked. So I think they did the wrong one on that one. That's why they ended up coloring it and then doing this side. Okay, that's all you have to do for your extra credit. Again, it can be 100 on the daily grade, or it can be 5 extra points on an assessment. What am I thinking right here? It is due Wednesday when you come back to school. The next time I see you, you're turning this in. So, if you can look at this one right here is styrofoam. You can buy one of those styrofoam paper, the poster boards at Hobby Lobby or Walgreens or something. Cut it up and hand it to your friends, and you can all each have a triangle. It needs to be bigger than my palm. This one right here, whoa. Probably not bigger than my palm. Alright, so just make sure. Cardboard. You got a cereal box at home? Go for it. This one right here, Miss Weimar took. You have a pizza box? You all eating pizza this weekend? Please don't give me the greasy sides. Don't give me the greasy sides. Give me the top. Alright, no food on it, please. Cut your pizza box, alright? You have shoe boxes at home? Cut the shoe box up. Some type of cardboard. If you want to be super extra and cool, which every year we do have super extra cool kids, you can use wood if you like carpentry and want to get into that, you can use wood. I have some of those. Some people like using drywall, but not the part that crumbles. You know what I'm talking about? I know some of y'all's parents do amazing things in their jobs, and they have stuff like that lying around. You can just get a knife and box cutter and cut that up. That's perfectly fine. All right. What can you not use? If it wilts when I do this, you cannot use it. All right. Do not use paper. Do not try to glue a bunch of papers together to make it heavy. No paper. I don't even think cardstock is good enough, just because if I put it on my pen and it wilts, like it'll be an automatic 0. Any questions about the extra credit assignment? How do you do it? How would I do this? Yeah, get a ruler. Make a triangle, right? Personally, I would make sure that when you're cutting, you make them even, just so that you don't have to do decimals, but it's up to you. Let's say I do 10 inches, 8 inches, and 8 inches. Can I do an isosceles triangle? Sure. Can I do an equilateral triangle? Sure. Can it be scalene? It does not matter. This would work no matter what your triangle looks like. What are you going to do after you make your triangle? Find the medians. Find the midpoints. All right. I'm going to measure, and I'm going to get however many inches on each side. And then what am I going to do? I found my medians. I'm going to connect them. Like that? No. What am I going to do? Connect them to the vertex on the other side. Is this a super hard project? No. But look up. Does that connect beautifully? No. If you get this and then you do this, I'm throwing it in the trash. That is not a centroid. A centroid should cross at exactly, because clearly I'm not measuring these, so it should cross at exactly a point like that. I should be able to put a pencil like with lead and it work. I'm not going to do that to you because that gives you a very limited chance. I'm going to use, I'm actually going to use one of these pens right here, and I'm not going to have it on. I'm going to have it off. Okay? So it should work if you do that. You can color it, make it design, make it pretty, but that is your assignment. It should not take that long, and you get extra credit. Do you have to do this? No. What if you come in, not Monday, because I'm not going to see you Monday or Tuesday. What if you come in Wednesday, you're like, Ms. Olivares, I left it on my desk. I was doing it last night at 1 in the morning. So, sorry. You just don't get extra credit, right? All right. Do I have any other questions?
Will this be on Schoology?
I'm posting this video, so if you come back and look at the video for today, yes, I can probably add something in the homework folder in Schoology for you. Absolutely. That's a good question. Anything else? All right, for the rest of class, you are going to go into Schoology, please, and you are going to do this special segments matching activity. Go.